Good morning, guys. I hope you are well and those you care about are well. The homework from last night, from maybe Monday night, was question 3 here. So a car accelerates in a straight line so that its distance s from its starting point p after t seconds is given by the function, that thing there. So just looking at that, it's really confusing because there's loads of letters, so we might just break it down now. So there's this idea of a distance s, okay, from its starting point p. So graphically what that would look like is, if we have some point over here p, and the car accelerates in a straight line, so it goes in that direction. So that's the point p, okay. We will know the distance between p and some other point, it doesn't matter what we call that point. Okay, we will know that distance called s if we know how long it takes to get from p to that point. So that's all that paragraph is really saying. So we just have had information so far, we've had no question. The first question is, find the distance of the car from p after 4 seconds. So we have to find the distance of the car, we have to find this distance of the car, so this thing here is moving, from p after 4 seconds. So how far do we travel from here to here if the time is 4 seconds? Well, this thing up here is a formula for distance, right? So if I put 4 into that formula, so if I write out 4, s of 4 will equal to 4 squared, so that's going to equal 16, and it's going to be meters, so it's after 4 seconds. Okay, that wasn't too bad. Now, second question. The distance of the car from p after 5 seconds. So after 5 seconds, so what do you think we would do there? So we've worked out how to look at it after 4 seconds. So what do you think I will do for 5 seconds? Yeah. Okay, so that's pretty handy. Now, this is really what we were learning about on Monday. So the speed of the car in terms of t. The speed, really, really important word there, speed. A car accelerates in a straight line so that its distance s. So we only know about distance. We know nothing about speed so far. So how do we turn distance formulas into speed formulas? What do we have to do to this formula for distance to make it a formula for speed? Very good. So we're going to differentiate this formula for distance, and if we differentiate distance, we get speed. So the formula s of t is equal to t squared. We want to know that's distance, so this will be speed. We're going to differentiate this thing. To show we're differentiating it, we write s prime of t, and we differentiate t squared. Well, that's just one of our rules. That comes down to 2t to the power of 1, and we would write that as 2t. So the formula for speed is 2t. So that's this part here done, the speed of the car in terms of t. So we've looked at t there it is there. But then I suppose the question that should make it all make sense why we're doing this is the speed of the car after 4 seconds. So this is s prime of t, and we want s prime of 4. We want to put 4 into this formula, so it will be 8. So there was a slight error in the previous answer, so we're substituting in 2 times 4, which is equal to 8 meters per second. Okay, so the other question you had last night was, a marble is dropped from the top of a 15-story building. The height of the marble above the ground in meters after t seconds is given by the formula, whatever. So find the speed at which the marble hits the ground. So this thing up here, h of t, that thing up there, that's a formula for distance. Because we're told that's a formula for height. So height is just the same thing as distance, right? So that's a formula for distance. So how am I going to turn that into a formula for speed, which the question is asking me for? So what do I have to do to this formula for distance to turn into a formula for speed? Good, I'm going to have to differentiate this thing. So h prime of t will equal 0 minus, now to differentiate minus 4.9 t squared, well this 2 comes down, so he's going to be what, 9.8 t. So that's now a formula for speed. Let's go back to our question, because this is when it gets a bit difficult. So find the speed at which the marble hits the ground. The speed at which the marble hits the ground. So this formula for speed is in terms of t. So in order to use this formula for speed, I need to know the time at which the marble hits the ground. So how do I work out when the marble hits the ground? So I have a formula up here for all of the heights, a formula for that height. That's the building, by the way. So that's the building. We drop our marble. I have a formula for that height. I have a formula for that height. I have a formula for this height down here. And when the marble is on the ground, what's the marble's height? So when something is actually on the ground, how high is it off the ground? Good. Yeah, it's going to be 0. So it's 0 meters off the ground. So h of t, that's the formula for height, equals 44.1 minus 4.9 t squared. That's the formula for height, and I want to know when is the height equal to 0. When is the height equal to 0? So now that's just an algebraic equation. So I'm now going to do my algebra on this, and that will give me a value for t. And when I get my value for t, I can put my value for t into my formula for speed. So it's kind of a multi-layered problem. So let's take a look at solving this equation. Well, I want to get t by itself somewhere down here. So to do that, I'm going to do a load of algebra. And the first thing I'm going to do is have minus 4.9 t squared. So the first thing I'm going to get rid of is 44.1 on this side. So he's going to turn into minus 44.1 over there. Now, the next thing I'm going to get rid of is this minus 4.9. So we have t squared will equal minus 44.1. And what does minus 4.9 do on this side over here? He's going to divide. So we have minus 4.9. So t squared equals, I can put this chap here into my calculator. Minus 44.1 all over minus 4.9 equals 9 even. So t squared equals 9. And then t by itself, how do I get rid of the square? Good, so I'm going to take the square root of 9. So t is equal to 3. So it takes 3 seconds for the marble to go from here all the way down to here. So this question has really fallen apart because it's now asking me for the speed when t is equal to 3. So what's the speed when t is 3? So I go back to my formula for speed. So speed h prime of t equals 0 minus 9.8 t, and then at 3 seconds, h bracket 3 is equal to 0 minus 9.8 times 3. So we're going to have 0 minus 9.8 bracket 3, which is equal to minus 147 over 5. Let's get a decimal there. Minus 29.4. So that minus there is worrying me. So I might just think about that for a second and I'll get back to you. So, but when in the previous clip we had this negative answer, and what that means is that when it hits the ground, it's actually traveling back up. At the moment it hits the ground, it's also traveling back up with this speed, and that's definitely not what's going on in the model. So it comes back to the way the question was structured, and really the model at the start, that should have really been a plus there. Okay, don't be too worried about that. The crucial thing is that we now have an answer, and we're just going to take that as being 29.4 meters per second. Okay, so we're now going to move on to new stuff. And today's new stuff is going to be looking at second derivatives. So second derivatives. So if we have a function, let's say f of x is equal to x squared minus 2x minus 3. Well, if we differentiate that guy, we get this chap here, f prime of x is equal to 2x minus 2. And it's quite possible for us to do the same operation again on this thing here. And to show that we're taking the second derivative, f prime prime x is equal to 2. So to show that we're differentiating something and then differentiating it again, we write this thing here. Should that be 2? Yeah. Okay. So when we differentiate this guy, we get this guy. We differentiate this guy, we get this guy. So this is the second derivative of f. And to show it's the second derivative, we put in 2 little apostrophes. Now, let's take a look at what happens if we use the other system, kind of the more continental system, or traditionally continental system. So if we have y is equal to x squared minus 2x minus 3, well then we will have dy dx equals 2x minus 2. That's what we know anyway. But now, let's take a look at how they would write the second derivative, and they will write it out as d2y dx squared. And that's going to equal 2. So to show that we're taking the second derivative of y, we write this thing here. d2y dx squared. So just like this is pronounced dy dx, and think about that as being one big lump of symbol, d2y dx squared is also one big lump of symbol. So basically, to find second derivatives, we differentiate, and then we differentiate again. Simple. Okay, so we're going to use that new skill on page 526, question 11 of your textbook. So we're given this function here, y is equal to x cubed minus 3x squared plus 4x minus 2, and the first part was to find out what dy dx was. So that's 3x squared minus 6x plus 4, and that was the first part. And the second part was to work out what d2y dx squared was. So that means I have to differentiate this guy again, and he's going to basically differentiate this thing. So we're going to go 6x minus 6. So that's how to do finding the second derivative. And if you want, please do now have a go at page 526, question 12. So take a few minutes to do those now. Okay, so hopefully you tackled them and hopefully you got up to part 3 anyways. Let's take a look at how we do part 3. If you're stuck with any other one, send up a message or something on Edmodo and I'll try and make a video of it for you. So let's just take a look at part 3. So we have y is equal to 1/3. That's not a very good 3. 1/3 x cubed minus 8x squared plus 3x. So we're asked to find d2y dx squared, I think. So first step is to find dy dx, and that's going to give me, well, okay, so we probably haven't dealt too much with fractions here before, but we know our rule is going to stay the same. So this 3 comes in and multiplies this guy. So what's 3 times 1/3? Well, if we have 3 1/3, that's just the same thing as 1. So we have 1x, and then the power gets reduced by 1, so that's x squared minus 16x all to the power of 1. We won't bother writing in the 1. And then what happens to this guy here again when there's just x's by itself? Yeah, it turns kind of the x just disappears. So making that a bit nicer looking, dy dx is equal to x squared minus 16x plus 3. So that's what dy dx is, and if we're asked to find d2y dx squared, that's going to equal 2x minus 16. So we differentiate our differentiated function. That's really all we need to know about second derivatives. We're now going to take a look at what they're useful for. So on Monday, we had this concept that speed is a rate of change of distance with respect to time, okay? So to get a formula for speed, we differentiate a formula for distance. And I also briefly introduced that acceleration is rate of change of speed. So if we're given a formula for speed, we can turn it into a formula for acceleration by differentiating it. So to get a formula for acceleration, we differentiate a formula for speed. So you just need to accept that as being a fact. Okay, so we're now going to take a look at page 538, question 8. So I think you probably have seen a clip of that just a few seconds ago. And we're given this function here, s is equal to 3t cubed minus 4t plus 6. And that's a formula for distance. We want to know a formula for speed. So how do we turn a formula for distance into a formula for speed? Yep, so we write out ds dt is equal to 9t squared minus 4. So in case you didn't get that, to go from distance to speed, I differentiate distance. And that gives me this thing here, so that's quite nice. And I want to know the speed after 1 second. So what will I let t become? So ds dt at 1 equals 9 bracket 1 squared minus 4. So that's going to equal 9 minus 4, which is 5. So the speed after 1 second is 5. Okay, next job is acceleration after 3 seconds. So the acceleration after 3 seconds. So I have a formula here for distance. I turn that into a formula for speed. So how will I get a formula for acceleration? What do I do to this guy to turn into acceleration? Yes, so I'm going to differentiate this guy again. So we write out d2s dt squared equals. So we differentiate this guy to get this guy, and this will be acceleration. This will be speed. So then we get 18t minus 4. And that's a formula for acceleration. And specifically we want to know acceleration after 3 seconds. So at 3 seconds, m dot dot d2s dt squared is equal to m18 bracket 3 minus 4, which is equal to 3 18s. That's 30 plus 24 is 54 minus 4, which is equal to 50. So the acceleration at 3 seconds is 50. Okay, and then the last part is kind of, they get you thinking about acceleration, and you kind of think about acceleration, and then they ask you the question about speed again. So we have to get out of our formula for speed, for acceleration, and get back into our formula for speed. So we want to know the formula for speed, which is 9t squared minus 4. And when is this formula for speed, when is that equal to 0? Well, I suppose there's a number of ways we can solve this equation. Probably the handiest way would be to just do some algebra. So let's go through it now. So we get 9t squared is equal to 4. I want to get rid of this 9. This 9 is multiplying the t squared. So to get rid of multiplying by 9, I'm going to divide by 9. So I end up with t squared is equal to 4 all over 9. So t by itself will equal to the square root of 4 all over 9. So t equals 2/3. So the time at which speed is 0 is 2/3 of a second. So 2/3 of a second after our experiment has started, the speed will be 0. That's a bit weird. So what's going on there is we probably are throwing something up in the air and it's falling back down again. So when we throw it up, it keeps getting slower and 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 slower until it reaches the very top and its speed becomes 0 and it starts falling down again and gets quicker and quicker and quicker and quicker and quicker. Okay, so what's going on there is that at 2/3 of a second it's probably reached the maximum it's going to get to. So that's pretty much the learning for today. So basically it revolves around to go from a formula for velocity or speed to a formula for acceleration. We differentiate the formula for velocity. Now, in the Leaving Cert, guys, the examiner isn't really interested in to see if you can work out the acceleration of some weird object. Okay, that's more for higher level. What the examiner really wants to see is, can you differentiate? Okay, so if you're in a functions question in your Leaving Cert, you're probably going to have to differentiate. So just bear that in mind that you're going to get loads of marks for doing the differentiating. And even if you don't know what to do with your answer, well, you're still after picking up loads of marks. So practice your differentiating skill. And we'll start looking at papers over the next few days and see what type of questions come up. And yeah, so we should be in good stead to answer the calculus questions on the papers then. That brings me to my next point. A request from a student came in to start doing some revision. So I hope to finish this chapter on calculus on Friday. And so on Monday, my plan for revision of older stuff will kick off. And what I plan to do there is we start at the start of the papers and we do 2019 paper 1, then we do 2019 paper 2, 2018 paper 1, 2018 paper 2, and so on and so forth. So we should be covering we should be doing, a load of revision. Yeah. So definitely before Easter we'll have started our revision. Now, obviously this is a lot more awkward than if I had access to you in a classroom, but sure, we'll do our best. Just to keep you guys ticking over for the time being, homework tonight will be page 539, question 13. If you have any questions about anything, please send me a message on Edmodo, or you're not able to comment on the YouTube videos, but anyway. So probably Edmodo is probably the handiest thing to send me a message on that. It's better if you can let the entire class see the question, because if I need to answer it then the whole class benefits. And I suppose, guys, stay safe and keep washing hands.